We'll start right away with our first keynote speakers, and Fabio and Harold. And while they set up, we'll make ourselves very comfortable here. There's no popcorn, but the shades are going to go down so we can actually have a better contrast. So Fabio and Harold are from EA, but they have been there a long time. So Fabio for 17 years, if I'm mistaken, you 20 years, so very senior people from EA here. But they're going to talk about more recent things, and especially the role of AI and machine learning, the role it's playing on games, play games. Fabio is the head of machine learning in EA, and Harold is the head of product for innovation, technology growth. So we're very, very happy to have you here. Thank you for accepting the invitation, and we are super excited to see what you have to say. Thank you again.
First of all, thanks to the organizers for giving us the chance to actually kickstart this conference this year. And yeah, today we're going to spend roughly 1 hour together, and we're going to, it's maybe not your typical talk, but we're going to basically reflect on the recent advancement in AI, what the significance is, and what we think the impact and the challenges and the opportunities for the game industry are. So before we dig in, a quick intro. My name is Fabio. I've been in the industry for 21 years, 17 of those in EA, and I specialize in character animation and physics. And my interest in ML is actually quite recent, around 10 years. It was a visit to SIGGRAPH that opened my eyes to the untapped potential of using machine learning for character animation. And the rest, as Seinfeld would say, yada, yada, yada. Today, I'm head of machine learning for EA Sports.
I'm Harold Chaput. Again, thanks for having us here. I'm head of product for EA Tech Growth Strategy, which includes a couple of organizations. I've been at EA for 20 years. I started at EA, so I've been in the AI biz for a while. I was sort of an AI hipster. I was into it before it was cool. I got my PhD at UT, and then I started as an SE1 at EA. And I became TD of a few game teams, and then I started combining my game experience with AI research about 5 years ago. And now I'm head of product for Tech Growth, which includes the seed applied research team, as well as external partnerships and academic liaisons. So that's me. You guys can get up. Also, fun fact, I replaced this picture of me because I think this is a much better picture of me. Don't you guys think so than the one? I don't know. I couldn't figure out which picture to use. I don't know. I'm not one to do pictures, but yeah. Anyway, why don't you go ahead and...
Okay, so, yeah, no. We can do it. Okay, so in case you haven't noticed, we are in the middle of a lot of people, including media outlet, refer to the AI revolution with products such as ChatGPT, GitHub Copilot, Adobe Firefly, and we've been teased with also more powerful and sometimes scary models like Sora. So these products are not only shaping the market for AI as a service, but I also think they have a huge impact, potential impact on a lot of industries, including our own, which is the game industry. So how did it all start? You guessed it, November 30th, 2022, the release of ChatGPT. There was a huge media coverage to the point that my dad asked me about it, and that's how I measure the impact of technology, if my dad asks me about it. And, honestly, to be honest with you, back then I didn't care that much because I played with GPT when the paper was released, and, I played with the demo on Hugging Face, and I thought, okay, yeah, sure, it's going to be cute. But I didn't realize that it was like a website open for everybody with a little bit of patience because the servers were clogged. Anyway, at one point I tried, and I'm like, okay, wait a second, this is different. And it wasn't only me, like 1 million users in 5 days is quite an interesting number. And I kind of want to reflect a little bit of why ChatGPT was so impactful and all the product that came after. Well, the first thing, and I can't stress this enough, it was a product. It was not just a paper, an academic advance. It was something in the hands of everybody, a product. And if you work in the industry, the giant leap that it takes from going from a demo or a paper to an actual product. And the other thing is that I believe that, and this is true not just for ChatGPT, but for every large language model, it's a new interface. It's a new interface between humans and machine. This sounds a little bit hypey, but bear with me. Like, if you think of the history from the Babbage machine going on, it's 200 years of humans trying to speak computer language. And, we had several layers of abstraction, and, languages evolved so that we could get closer to natural language, but then boom, there's a leap. And now computers are learning to speak human. This means that now natural language is the interface to program a machine. And this is huge because, in my opinion, it lowers, if not completely removes sometimes, the barrier of competency from a lot of tasks. I have people in EA, colleagues, that are doing today scripts in Python, and they send it to me for review. And before, they couldn't even entertain the idea. So I think that that's a pretty it's a pretty big proof that today, a lot of people can do things that they couldn't do before. And the other thing that I wanted to point out, and this is a little bit philosophical, so just bear with me for a second. I think that large language models are peculiar because, at the end of the day, a large language model is a next token predictor given a bunch of context. But because the output of the prediction and the conditioning are natural language, you can actually put in the context the goal, the control signal for what the output will be. This is not true for everything. Like if I can build today a transformer that predicts the next pose for character animation, but in order to control, the control signal cannot be motion itself. It's just awkward. I need layers of translation. With natural language, they coincide. So that's why with just a simple next token predictor, you can build a chat and an agent. But that's enough rambling, so I'll leave it to you.
So then, but I want to jump in and also make sure that we provide the context that I hear a lot of people talking about, like, how is AI going to transform video games? And the truth of the matter is that AI has been transforming video games since video games. We've been like, I'm trying to think of, like this is a space war game that was done on a mainframe in 1963, and like it had an AI opponent in it. I mean, like, so AI has been in our games since the very beginning. I'm hard pressed. I've asked rooms full of AI PhDs, is there another industry that has used AI for so long in production as video games? I can't think of anyone. No one else can think of one. We've been in the AI business for a while. So while this is a revolutionary moment, it's very poignant for us in the sense that we're already there, but it also, I think, affects us very deeply. To kind of give a few examples here, AI opponents in Space Invaders in 1978 is sort of like when really sort of people started to notice that, oh, you can have like an AI controlled opponent, it can be a bit frustrating. Level generation was happening back in Rogue in 1980. Pac-Man actually incorporated dynamic tactics where it actually, the opponents had personality and they reacted to how you played the game in order to change their strategy. And procedural characters, Spore just being one example. I mean, so like AI has been, content generation, all different forms of AI have been in video games for a very long time. And I don't think that that's just a coincidence. I think it's actually, there's something deeper going on. When Alan Turing put the word artificial intelligence together back in 1950, the way that he used to describe it to us in a way that could be intuitive was in the form of a game, what we now call the Turing test, right? He proposed this game that would help us understand what is the difference between a man and a machine, right? And so I really do think that there is something like deeply inextricable about artificial intelligence and video games in the fact that there is some other thing going on that's deeper that compels us, that we find interesting. And so I think that with this revolution in AI that's going on now, if you want, or evolution, whatever you want to call it, like I think it's like it's we're already there, but it actually is hitting the DNA of what games really are.
Yeah, and actually it's true. Like a lot of people ask me, is this a revolution really, or is just a fast evolution? And for me, the real revolution again is what I was saying before. These are products. It's very different from what happened before. Anyways, this is all good and dandy. Like it's an AI revolution or evolution, call it whatever you want. But what does it mean to the game industry? And these are the questions that me and Harold need to answer in EA. And I think that when you're thinking about how to include a new technology, well, not new, an evolved technology into your business, a good place to start is ask yourself what the challenges are. What are you trying to solve? What are your biggest friction points? And, for the game industry, this is just a reductive list. But I think that the most prominent are meeting the increasing demand of content, striving for authenticity, for player engagement, and also innovate. So we're gonna go through them quickly one by one. Demand for content, as I said, being new animations in FC, FIFA Football Club, or being new quests in Cyberpunk, in the DLC, or just simply, cosmetics for Fortnite or whatever game you want. These, our users consume a lot of content. So there's a lot of demand for it. And, there was a quote from somebody in EA that said there's not enough artists in the world to do all the assets that we need to do for the next iteration of game in 5 years. So, but I don't think that this drive for content is coming only for the gamers. As developers, we're getting excited about this thing. Our scopes are getting bigger. We want to make better, bigger games. So, combined, this results in a pretty huge demand for content.
I mean, it's been my experience, by the way, that if we find a way to make assets faster, by cut the time in half, we don't cut the schedule in half. We do twice as many assets, right? I mean, it's always the way it works, because we want as much as we can possibly get.
Yeah. And, I had this slide called realism before, but then I changed it to authenticity. It makes sense to talk about realism if you're doing an F1 simulation and you want it to be as close as possible to the real thing, or if you're striving for a game that looks exactly like a body cam from a member of a SWAT team. But in general, it's more about authenticity to whatever the vision of the person who thought about the game is. The fact that the game could be a completely fantastic world, but the grand vision is hard to hit. So we want to be authentic to this vision and engagement. And here I don't mean how much are we going to keep users glued to the screen, but it's more like how do we create experiences that are really touching to and engaging and that keep the users involved, being the crazy NPCs in Red Dead Redemption that you can follow around at different times of the day and they appear to have a life of their own, or being the Nemesis system in Shadow or Mordor, or simply the way the enemies in Last of Us 2 flank you and react to whatever you're doing. These are engaging experience, and it's not hard, and it's not easy to do it. So if these are the problems, if these are the challenges, what should the focus for us be? And me and Harold, we came up with these 3 pillars: empowering creators, abstracting process, and transforming experiences. This is not necessarily a timeline, but I do believe there is overlap, but I do believe that left to right is effectively what's going to happen.
It's kind of short-term, medium-term, long-term.
Exactly. So starting from empowering creators, even though I have a role, head of machine learning, that to most of my friends and family is equivalent to being the minister of magic, I remain a very practical person. And I think, as a practical person, I see a low-hanging fruit here. And I say it in EA as well. These are products. The AI revolution is bringing up tools, off-the-shelf tools that we can use today. And we are using them today. I use GitHub Copilot every day. This is not my code. For obvious reason, I can't show you my code. But, if you took GitHub Copilot away from me, I would be really sad today. I remember at one point I wanted to turn one of the models from my team into a microservice, and I knew nothing about web development. And I put up a server, a fast API server with ChatGPT and GitHub Copilot quite fast. And to me, it was a much more engaging experience than just rummaging through documentation to understand how to use the library. And, I actually used several applications such as DALL-E, Midjourney, and Leonardo to create most of the images that you see in this presentation. And before, it would be hours of Googling, hoping to find something that is close to what I wanted to show. And I actually even used ChatGPT at the beginning to brainstorm ideas for this presentation. And it's just fun. So, and these are not just end products and tools that we can use. I think that, specifically with LLMs, there's also a change in the way we build application. This is a screenshot that I took from a keynote from Andrew Ng, and it's basically providing an example of how his team, development team, just 1 or 2 years ago, to create a sentiment analysis app for restaurants, it would take 1 month to get the label data, 3 months to train the model, and 3 months to deploy. And today, specifying a prompt and using an LLM, in hours or days, you have a product that you could potentially ship. It makes it a little bit too easy, but it's true that it's a drastic difference. So, you can also get creative. You also can mix and match. It doesn't have to be all AI end to end. Like, this is a silly example that I think is going to illustrate what I mean. Suppose that you want to do your own research in crowd simulation. You have a bunch of papers. Don't read the abstracts. Those are generated. They don't mean anything. But you have a bunch of papers, abstracts, and you want to rank them to see in what order you should read, which one you should skip. How are you going to do it? One way would be, to get your LLM to analyze each one of these abstracts against the description of the problem that you want to solve. But you would end up with a wonky scale, a lot of duplicates. So why don't you plug it into a sort algorithm? At the end of the day, you just need a comparator that returns -1, 0, or 1. So you could provide abstract I and abstract I plus 1, provide the problem description, and then a prompt to say, okay, you tell me which one is more relevant to the problem I want to solve. It's going to be the slowest sort you ever done in your life, but it's going to get the job done. So these are all building blocks, new building blocks, more powerful building blocks that we can use together to build even more complex structure. And this is a process that is going to, it's a good segue for the next step, which is abstracting processes.
Right. So beyond taking the systems that we already have and finding ways for AI to make them better, I think it's going to force us to rethink the processes that we already have. And as an example of, just to kind of walk through an example, let's talk about the process of making a cutscene. Okay. So today you got to write a script. You got to do performance capture, voice capture, level design, character animation, and then with that you have to do lip sync, and then you have to, in your cutscene, you have to incorporate all your character customizations, the weapons and props that the character has, any environmental customizations that you have, and you got to do all that rendering in real time. I don't know if you guys know anything about that, but that's a thing that you have to worry about too. So all this stuff, I mean, it's a lot of it. This is a huge end-to-end process just to get a cutscene into a game. This takes forever.
Which is not even the final.
It's exactly right. I mean, because what happens then is, like, if you want to change this, if you want to just make a change in the script, then you've invalidated almost all of the stuff that comes after that. You have to go back and do all of this work on its own. And some of this stuff is done by a machine today, but a lot of this stuff is done by hand. And so if you're making a game and you're looking at your cutscene and you're thinking to yourself, man, this would be a lot better if this person said this instead of that, you're thinking about this and going, yeah, I'm not doing that. I'm not going to, no, there's no way. I'm just going to set the schedule back just because I want to change a line. Like, there's no way I can do that. Right. And so especially, so, I've worked at BioWare. I worked on Mass Effect Andromeda, like, hold your applause. The real serious problem there when you're doing this, especially when you're doing this with like branching dialogue, is that you have to skate to where the puck is going to be 7 years from now. Right. I mean, because it takes so long to make this. And so when you finally see it all come together, if you want to make changes, you're basically rewriting the game. Like, this is a disastrous workforce, right? What if we could just,
we still should do it.
And somehow we still do it. Miraculously, we still do it, right? What if it could just be this? What if those things that we talked about could just be the inputs to a model? The effects that we want to have are modulations to that model, and the thing that gets output is a cutscene. And here's the thing about this slide, is that if I bring up this slide 6 months ago, people are rolling their eyes. But right now, each and every one of you are thinking of Sora or the components that could go into this thing to make this thing possible. It just took 6 months. It just took 6 months to get from science fiction to, oh, you know what? I don't know, maybe something, maybe, I don't know, probably won't work, but we could try it. You know what I mean? That's all it took. Like, that's how fast this stuff is happening. And the thing is it's not like there isn't a need there. There is definitely a need there. And if there's a need and there is a solution, even an imperfect one, people are going to flock to it. So I think that's like why this moment is sort of upon us. And so, like, this is sort of, again, a little more science fiction-y example, but Fabio has a bit more down to earth example that he wants to walk through.
Yeah. So as I said before, my field is the field of character animation. And I kind of want to argue that character animation has been chasing abstraction for a long time. And this happened basically on two parallel streams, the acquisition of the data and the actual runtime controllers that play the animations in the context of a game. So we went from keyframe animation. If you remember, the first Tomb Raider was not using motion capture. It was like hand-keyed animation, and so many games before it. We abstracted from this problem of, posing a character in your DCC tool, like transform by transform in a hierarchy of matrices, to motion capture. Now you just put sensor on an actor, you instruct them to do things, and after the solve, you get the animation out. So we abstracted here. We went from a completely manual process to something that delegated high level to an actor performance. And for controllers, for 20 years, I mentioned before that to me, SIGGRAPH was an eye-opener. In animation, and I think a lot of renderers agree that rendering was so far ahead of animation, character animation for the longest time. Why? Because for 20 years, all we have been doing is like taking clips, cutting them by hand to fit the demands of the game, putting them together in a finite state machine with hard-coded rules and blend space if you were very adventurous. And that was that. There's nothing more advanced than that. And then at one point, we switched to something that was a complete paradigm shift, which was, okay, what if you take your corpus of motion capture data and you just compile it to, a high dimensional space where each point is a pose, and then your problem becomes a problem of nearest neighbor. So now you have your feature vector, which is the current pose, a fragment of the trajectory for the root motion in the past, 1 second, 1 second in the future that defines where you want to go, slap all of that in a feature vector, and then just do a KNN on your database. And you can see that in action in NHL, and it works extremely well. And so well that we shipped it in NHL, as you can see it there, and those are also all the games that EA has shipped, including Mass Effect Andromeda, yeah? All the games that we ship with motion matching. So where do we go from there? KNN, and this is just a cute representation of a KNN search. It works extremely well. Sometimes it's hard to encode in the feature vector the goals that you want for your task. But it works great, but you still need to keep the animation in memory. You still need a database to do your KNN. So the next natural transition would be, okay, why don't we take all this data and we use it that training set for a neural network? And keep in mind, this is not an actual architecture, but imagine a multi-layer perception that takes in input the current pose at frame I, and with the trajectories that I mentioned before, and then just generates, skipping entirely the KNN phase, just generates the next frame. So at this point, again, you're abstracting from the data. You train the model, and then you throw away the data, and you don't need it anymore. Again, a process of abstraction. We're good with time, don't worry. And also for the data, we abstracted there, because you go from motion capture, which is amazing, but you still have actors that you have to bring in, and you need to instruct them. And it's not that easy to instruct actors to do complex things, especially when it comes to sports games. You're never going to reach, suppose that you want the fastest acceleration possible. The motion capture studio is only that long. This guy's not going to smash himself on the wall. So, it's never going to be as accurate, as engaging as actually capturing the people, the real athlete playing the games. And this is what we did actually with FIFA. We went to Spain and we used this, what are they called? Accent suits. Yeah, which basically, is a mix of inertia, and then we had cameras to, minimize the drift. But now we had the performance of real athlete going at it, full on, full steam, which is so much better than the performance of an actor. I think these two forms of data are complementary, but the future clearly is to capture the essence of the sport with real athletes. And this is, again, as I mentioned before, this is exactly what FIFA 22 has accomplished with the technology that has been released as has been called publicly as hypermotion. And I'm not going to talk about the nitty-gritty details. There's a GDC talk from GDC 22 from my colleagues Ryan Cardinal, David Wong, and Luke Shear. If you're interested in knowing more, please go check it out. It's a really cool talk, and they talk a lot about the details of the technology. And incidentally, it's curious to see that the developers don't call the technology hypermotion internally, but they call it GDA, which stands for goal-driven animation. And this to me is exactly where the next step into the future is going to happen. So what's next? We're going to go and synthesize motion from very high level goal-driven animation. We're going to abstract even more. And now we're going to try to generate, synthesize animation from goals as high as go and pick up that weapon, go and hack that computer, intercept the ball that is flying now. And, the academia is already going there. You see here 2 screenshots from a paper from Guy Tevet, the human motion diffusion model. And, it doesn't necessarily have to be text to motion. I honestly don't think that text is the best way to define motion, especially when it comes to video games. But, it could be a set of constraints. It could be a target pose. It could be, a space-time mask of anchors. But this is what we're going to do. We're going to go for a high-level goal, define the constraints, and then generate motion based on this high-level goal. So, to you.
Yeah, so all this is going to happen, but this is not where the big revolution is going to come from in video games. It's going to come from the fact that games are going to change. I don't need to tell you guys that games and tech have been driving each other since games. We've had, rudimentary 3D games, then we had GPUs, and now we have these amazing 3D games. Even with simulation games, the demand for more multi-core processing has driven like really high-level simulation games and multi-agent systems and dynamic systems to allow for these incredible simulation games that we have today. We had multi-user role-playing games back in the 80s, but you had to be on a mainframe. When the internet came along, all of a sudden, now we have things like World of Warcraft. We have Battle Royale games. Like, these moments come along, and they change the way that we play games, right? They introduce new kinds of genres, things that at the time seem miraculous and then become just another family of games that we make. So the same thing is going to happen on the AI front. But what's interesting about the AI, and the way that this, there's 2 things that make this one different. AI in and of itself is compelling. I put up some numbers for ChatGPT and Midjourney. The interesting thing is the duration, how long people stay there. Nearly 8 minutes on ChatGPT, like nearly 11 minutes on Midjourney. This isn't YouTube numbers, but this is definitely like Instagram numbers, right? People spend time when they go, right? They actually are interested in it. So, and the things in and of themselves are compelling. You yourselves, I'm sure, have played with these tools or tools like them, and you want to go back to them and you keep playing with them and stuff like that. Playing with them is sort of the business we are in. So like it's already comes pre-interesting, right? But more than that, like I was saying before, AI sits at the core of games. So it's not just that it's going to introduce a new aspect to how we play games. It's going to really kind of like, it's going to modify the DNA of the games, and so like imagine, if you will, what if, like instead of AI opponents, we have AI companions, something that was like a bit more sentient, a bit more aware of what you're doing in the game, something that can go along with you, travel with you, give you advice, maybe screw you up a little bit, but actually be like a really compelling companion, another presence in the game with you. What if instead of world generation, we had planet generation? Sorry, my animation's a little off here. We had like actual planet generation, which beyond what we're already doing in No Man's Sky, something that's actually photorealistic, something that's controllable by the storyline, something that supports the storytelling that's happening in the game. What if instead of dynamic tactics, you actually had personalized activities that were generated in the game, something that could notice how you play and what you like to do, and then create quests for you to go and do that will make you really interested and satisfied? What if instead of procedural characters, we could actually have a procedural narrative? Like I was saying, the effort going into a branching dialogue game, which is really replayable and compelling, it's a tremendous amount of effort. But if that is something that can be done on the fly with all of these other techniques connected to it, you basically are coming back to now you have like a dungeon master, who's controlling the game for you, and it's sitting on the disc in your console, right? It doesn't have to go out to the server. It doesn't have to be another person. It can be there, and it can be there for you. Every single person can play the same game and have a completely different experience, an experience that they like, an experience they can tell other people about, an experience they can share, right? What if? I don't know. Nobody knows. That's the point, is that like we have all these challenges that we have to tackle. There's, I mean, you, I don't know if you want to speak to this, but like, yeah, go ahead.
Okay, yeah. So, it's all great, but it's not all unicorn and rainbows.
No.
There are adoption challenges to actually integrate this kind of technology into our, what we do in development. And, I just listed a bunch here, and I think it's also a good point for this audience. I did a summit in EA Vancouver last year when I invited like the most active academic people in character animation, and basically the meetings were like, you tell us what your latest research is, and we're going to tell you what the problems that we need to solve are, because academia and industry have different focus, but together, we can drive each other even further. So there are things that academia sometimes doesn't care about because they just don't know that those are problematic for the industry. So, I take these as a chance to put them in front of you. And the first one, which I think is like, it's obvious to everybody, transparency and control. Like you could have a model that performs 95%, and, give you what you want. Again, a runtime in game. But that 5% of time when it screws up, like what are you going to do? Like you need to be able to control the outcome. And not only that, like the way that we have been making games for 30 years, we want so much control. Like I had to change animation controllers because the guy wasn't leaning forward enough and he didn't give the sensation of acceleration. So, we want total control, and these black boxes are not giving it to us. So we either find a way to pry open the black box, or we need to give away a little bit of control, which I think a little bit of both eventually is going to happen. But it is problematic. And also models adaptability. Like to give you an example, there are situations, for example, again, character animation, where even if you had like all the data in the world, like all the motion capture data that completely defines the manifold of human motion, you have that. But then in game, you have to deploy animations that have acceleration curves that are superhuman. So, but you don't have ground truth for that. So can we create models that understand the atomic components, like the primal motors of actual animation and human motion so well that they can abstract and, go out of distribution, and just by changing the law of physics can generate animation that is actually plausible to the eye, even if it's not realistic. That's a problem for the industry. And, the other thing is that the way we make games is incremental. Like even the thing that you were showing with the cutscenes, I said that's not even the final cutscenes because we need to iterate, and iteration needs to be fast. Finding fun, finding engagement is an iterative process. The whole process of creation is iterative, and it needs to be fast to be efficient. So, and also for bug fixings, like it's unacceptable for us to have, suppose that you have like a CPU AI that you're done with reinforcement learning. A bug comes in, it's not sustainable that you have to retrain the model from scratch. So we need to find a way of, patching either with fine tuning or distillation, whatever it's going to be, but it's needed to actually ship a game. Otherwise, waiting, you can brute force it, put everything on a server and train as fast as you can, but it's just not sustainable. Also, problems of catastrophic forgetting, your databases are going to grow huger and huger, like something needs to be done. And, it's also integration with existing systems. There's nothing really we can do here, but, right now, putting ML models inside the game kind of feels like bolting stuff on the side. It doesn't feel, the existing systems are not designed to receive them, and we cannot just strap it on. But eventually, we're going to change our workflows. We're also missing the infrastructure that we need to actually make this process efficient. But, it's going to be painful, but eventually we're going to get there. And then again, to the point that you were making, like, it's not sustainable to think that all the invocations to the model that we have are going to be on a cloud somewhere. It could even be like a service provider. Like if you try to see how much they would charge you today, and imagine that a game like FIFA with millions of users, everyone use your token API, they're going to go bankrupt in like 2 days.
Yeah, so, games in particular are counterindicated for cloud anything, because the more popular it is, the more expensive it becomes. Yeah. It inverses the usual money making model, and the business people no likey. They don't want any of that.
And eventually, so we need to go on device. And, the models that we have today, especially for LLMs, are not there yet. There's work being done, again, as I said before, distillation and other approaches or pruning. But eventually, the hardware is going to change as well. We don't know much yet. And the things we know, we can't tell you. But, we're getting there. But this is the future. Like, we need models that are also, more compact and easier to, less computationally expenses. And I would dare to argue that these models are so big today because we don't really know what's going on. So it's kind of a brute force, get as much data as you can and hope for the best with this huge model that cost like millions in electricity. But eventually, when we really, really understand the core concepts of whatever you're trying to do inference on, I believe that the models are going to be smaller and more efficient.
But as was alluded to, as what Fabio alluded to, is that this is not just a technological problem. This is an entertainment problem. This is an engagement problem. It's not enough to solve these technological issues. We have to find the fun. And so as we solve these things, we're always connecting with people who think about games, who design games, yourselves and other people as well, to figure out okay, so this is really interesting. We've solved this problem. Now, how can we leverage it? How can we use it to really make a really great entertaining experience for the people who are playing our games? Things like engagement, accessibility, storytelling, expressiveness, personalization. These are the things that we're trying to support within games. This is what's important. I pulled this. This is one of the first ads that EA put out about them putting their mark on what is a game really? Can a computer make you cry? This emotional experience, this entertainment experience, is at the core of this business. It's not just a technological problem. Right?
I thought it was the Beatles.
It does. They did sort of make them look like rock and rollers for some reason. Boy, those were the days. But I think it's really important to remember that we're doing this for the service of showing people a good time. And so as we're solving all these problems, that's the thing we have to remember to connect it to. But it is going to happen. It is happening now. Someone is figuring it out. Some things have already been figured out. A lot more stuff is going to get figured out. And this is what's really cool about right now, is that we get to watch this revolution happen. We know it's about to happen. We know it's happening before us at this very moment. We don't know how this thing ends. We don't know where it's going to go. But we get to sit and witness it and participate in it and direct this thing to where we think the future of gaming is going to be. That's pretty exciting. That doesn't happen very often. And when it does, it usually happens, it blindsides us. We don't usually see it coming. We can see this one coming a mile away. It's happening now. And it's pretty cool to get in front of it and be a part of it.
Yeah, well, that guy from 2 Minutes Paper, Caroli, what does he say? What a time to be alive.
What a time to be alive. Yeah, absolutely.
Anyway, we're done. Thank you, everybody. We're festive.
Yes. Thank you so much for this very exciting and enthusiastic talk. It's time for questions. Okay, we're at one here.
Excuse me. So I'm a game professor now, but my training is old school cognitive science from Berkeley and CMU. And I wanted to ask more of a philosophical question, if I can. If you sort of look at the history of AI from a cognitive science lens, you have essentially a hype and buzz cycle. You have logic theorists originally with Herb Simon, and then that sort of disappeared. Expert systems in the 80s, that sort of disappeared. Deep Blue, and then that sort of disappeared. And now we have essentially neural networks with big data that's sort of driving large language models. One question I have is your thoughts on why isn't large language models just another part of the AI hype and sort of buzz cycle, in a sense of, I guess I remember reading recently article by Gary Marcus who's arguing that large language models are essentially autocomplete on steroids. There's nothing deeply behind it. And as a fundamental cognitive scientist, I am kind of curious about the more deeper questions that cognitive science is trying to address, which is how do we kind of replicate human level, not reactive, but more proactive, right? Planning, reasoning, learning from behavioral of other sort of people and so on. How close are we to that? And I love the tool level use of AI and so on, but I'm kind of curious as machine learning researchers, are we getting any sort of closer to that aspect of cognitive science
Other
AI?
ones?
Yeah, I'll take this one. All right. So there's two questions in there, and it's like, is this another hype cycle and like all the others, and what's so special about what's happening with large language models? Okay. So the first one, yeah, it is a hype cycle like all the others. Of course it is. But they didn't just hype and then go away. They became chapters in textbooks. That's the thing. It's not like it's like, oh, this is really exciting, and then it came to nothing. This isn't like, this isn't NFTs, right? I mean, this is like things happen. You have to remember. Sorry, is this getting taped? Sorry. Like A-Star was a big deal when it came out, and now it's like it's a algorithm you download, right? And so it's, yes, what's going to happen is we're going to get tired of what's happening now. We're going to call it like, boring. We're going to go into, another AI winter. I'm sure of it. It is the way of the world, but it will have its mark first. And just like every other one of those things that you talked about, they left their mark, right? They did change the scene. And I think what's happening now is it's changing the scene more. And so that gets to your second question. Why is this so different than the other things? And because I think this particular thing that's happening, especially with large language models, is that it's showing how wrong people were much more than the other revolutions in AI. People were convinced there were huge projects centered around common sense databases and the grounding problem that there was no way that natural language could ever possibly work unless computers have a sense of meaning to all the words. There is no way statistics and statistics alone could possibly capture language, right? I mean, this is like still being said in psychology, in computer science. I mean, it's still being said. And it's demonstrably wrong. Just get on ChatGPT and you can have a conversation that's at least as good as you can have, at least for a little while, with some of maybe the less inspired coworkers that you have. I mean, there's something there. I mean, so like I think that what's going on here that's really interesting. I mean, there are a lot of egos that are getting stabbed right now, because a lot of people are wrong, like the Chomskys of the world were wrong about language. That's a big deal. And I'm alone. Yeah. And so I think this is going to have more lasting power because of that. It's going to make us rethink not just language, but under like cognition and learning in general. I think now everyone's going to go back and go, what else did we get wrong? So I think it's going to have a bit more staying power than the other ones. That's just my opinion.
Hi, thank you so much for, the great talk. My name is Omar, I'm from NVIDIA. So I wanted to ask you, like, this is a practical conference. Can you pitch a roadmap for not something concrete that you're working on, but like how would you actually deploy this? And I'm asking not just in terms of tool reliability, also like a lot of these things cost way too much money to deploy at scale, right? So how would you incorporate something that is truly magical, like like an LLM service or maybe like a geometry generation service into a pipeline in a way that you can trust and you can say, well, I'm signing on this. This goes into production in 3 years, costs notwithstanding.
I don't think we have an answer yet, and I do believe that we're going to do this, guess it incrementally. So there's a lot of models that you can deploy today without having to to spend like entire weeks or months to train. I think the first phase is not end-to-end models. The first phase is like components that abstract parts of other systems. And I'm extremely practical when I think about character animation. So I stay away from end-to-end model. Like text to motion doesn't interest me that much at this point. But to your point, LLMs to do some of the dynamic things that we are, envisioning. At one point, we'll need to face the production pipeline, as you said, the cost of everything. Open source is going to get better as well. We saw the strides that Llama is doing. So eventually, again, I think we're going to get to smaller models that don't cost millions of dollars to train. I don't think I have a real answer for you, but in the meantime, while we wait for everything to go, there's things that we can do today, like the little components, the smaller system, instead of big end-to-end models. Does that slightly answer your question?
I guess my answer will come in a few years.
No, I think it's telling that the people from NVIDIA are asking the people from EA what the pipeline should look like. You know what I mean? It's like we don't know. We don't know. We have to hunt around and find out. I think we have some pretty good answers about some things now, but we got to try things, and we got to try. This is new, and so we have to figure it out. I mean, if I could get a roadmap for what this thing looked like, I'd go start my own business. I mean, you know what I mean? And so would we all. So I think we got to try things and fail fast and see what works.
Hi, thank you for the great keynotes. My name is Roberto. I'm coming from ARM, UK, right? Cambridge, UK. So it's great. I mean, I was thinking about many things when you were talking, and I agree with you 100%, right? But looking a little more to practical use cases, right? Right now, we can see that the biggest game engines like Unreal, Unity, Roblox, they are really introducing Gen AI in the asset preparation pipeline, right? But I'm just wondering, what kind of use cases are you thinking coming soon at runtime, which is where we will have more challenges, right? So, for example, you mentioned animation. Yeah, animation is already happening, right? Something that is happening at runtime, or also, let's say, neural texture. There was a presentation at GDC recently from what was it's Lafort, right? But what kind of other use cases EA, for example, is planning to implement at runtime? I was just wondering if you could say something about that.
Well, we can't mention any project, but to me, like,
that's
yeah.
It's pretty clear that
I think we have the slide about all the secret projects we have. Let's put that up. And
as a password, though. No, but jokes apart, animation is one, and the one that I'm closest to. But I'm also looking at others. Like even without disclosing any company secret, it's clear that CPU AI is another field that we haven't been doing. Very bleeding edge things. And like, I fell in love with reinforcement learning when I read Rich Sutton's book. But back then, at one point, I'm like, you know what, I'm done with this. This is way too flimsy. This is way too changing. Today, I think RL is getting to the point where it could be practical to do something with it. So, I don't have a roadmap, and there's nothing that I can point you to today. But like personally, I'm kind of going back to it, and I kind of want to explore if we can use it to do some more dynamic and more interesting CPU AI. And the other thing that I wanted to mention is that another opportunity of going data driven, with new level of abstraction, is that there's a lot of systems that before were kind of like compartmentalized, like there's animation, there's physics. Oh yeah, we haven't talked about physics. Character physics is very complicated, but usually there's AI, animation, character physics, rendering, and they don't talk to each other very much. Like I envision like systems that are going to be more holistic in the future. Like you can imagine like a common representation of the state of the game, the different system ingest and and process differently, but they can all communicate to each other.
Yeah, I mean, right now there are places, like I say, that AI is already being used in games. So those are going to be highly implicated for what's going to get changed. Like the CPU AI is a really good example. And I think that's a little more resistant to it because it already has come down the road so far. And so changing that and revolutionizing that is going to be a lot of work. But I think there are other systems in there that are using like, some form of logic and AI that can be done on device. But I think the other part too is a lot of stuff that's done, in the preparation of the game, if that can be moved to being on device, right? Like what we were talking about, like if in some future world we could, like the animation is a good example. Like if somehow the generating cutscene example like became real. I mean, what are the other things that if we could, we would rather do while the game is being played rather than while we're making the game? I think that's another place to look for where this stuff could happen. But that's at least where we're looking. I mean, and that a lot of that stuff's going to be hard to do, but it's getting easier every day. So.
Thank you very much.
You're welcome.
More questions?
I have a question. So from what I understand, like for most of the bigger LLMs today, like ChatGPT, they're not open source, so we don't have access to their databases and things like that. And training an AI model to do something like this would require like a lot of data and resources. So my question is, do you ever see this being harnessed by indie developers, or do you think this is going to be limited to like the bigger companies?
So if you look at the pharmaceutical industry, they come up with a new medicine and they have a saying there, which is that the first pill costs like, $10 billion and the second pill costs like 5 cents. And I think that's where we are with LLMs right now. The first one is going to be the most expensive one. And the second one will be less expensive. And then the third one will be less expensive. And, we're going to find a way to make these things more accessible, easier to do. I'm quite positive that Microsoft would love nothing more than to addict everyone to Azure and make sure that everyone was using that in order to get access to an LLM. I mean, of course, that's going to be the business model, but we're scrappy. We find a way to kind of make that stuff easier and easier. And I think that's a part of the problem that we need to solve. So information finds a way. We're going to like get access to this stuff. It is going to get used. Do we need, for example, a completely generalized any topic in the world LLM for each and every game, or can we like maybe just reduce it down to the very specific things that we need for that environment, for that experience, and make it a much more tractable thing for us to use? Is one avenue that we can look at, right? So.
It's already happening. Look at retrieval augmented generation. Like that's a way of going around the fact that you can't retrain on the latest knowledge. So it's going to be more and more of these, I believe.
So yeah, I mean, there's already stuff out there that that you could download and play with today, and that stuff's going to get better and better, for sure.
Thank you.
Do we have more questions?
Well, so I was thinking about like content generation, and I remembered my Spotify playlist and recommendations, the recommendation system of Spotify, that it seems that all songs that it recommends to me look like the same, although it's from different singers and different bands, they basically feel like the same. And sometimes when I played with generated content with LLMs or transformers, they always have this kind of, I don't know, but it feels kind of the same. Like you look at the image and you can tell, okay, so it probably is generated by this model or the other one. So how can we counter that? How can we avoid having this, like everything kind of looking the same, even though it's different or generated automatically?
It's funny because I actually have the opposite impression, especially when it comes to image generation. Like you generate something like, I don't like the background, and the next thing is completely different from what you wanted before. I find that iteration on image generation is actually the hardest thing today. Like it always comes up with something completely different. And along the same lines of the prompt, but like stylistically entirely different. So and also I would argue, sorry, I'm not really answering your question, but I'm just thinking along. Like to me, the idea that the variance is not that big is possibly a thing to exploit when it comes to games, because I think that the future is going to be where we give a little bit of control away, but we set guidelines with a specific standard deviation between what we want, and we get dynamic content with guardrails though. So I don't know if I want to answer your question because practically is not that interesting to me, and I'm not a researcher on generative AI, so. Yeah, I just gave you my.
Well, I'll answer your question. Okay.
Yeah.
All right. So I mean, and here's the reason why. Because right now in the music industry, the product is the song. Right. So the goal is to make a song that everyone will buy. And when you do that, whenever you try to get a mass market, you're going to regress to the mean. Right. There's going to be genres. There's going to be subcultures. There's going to be cliques. But honestly, if you want like a home run, Disney's going to make a family-friendly animated film, and then everyone's going to go and see it. I mean, that's what you're going to get. Things are going to change when the model is the product, because then it's going to be about what you can do with it, right? right? If it's just about what the application is, it's going to be mainline. But then when it becomes like a device that does things for you, then it's going to be about personalization and versatility. That's actually, and so like I think we actually can speak to that kind of deeply, because that's what's happening in the games industry today, is that people don't want the same experience all the time. They want to personalize it. They want changes. They want new seasons of content. They want they want to stay engaged with it. They want something new all the time, right? But right now, all that stuff is done by hand, right? And so if there was a way to make that experience something a little more person to person, you know, other than giving each and every person their own like content manager that they can do it in the game, if we can automate a lot of that stuff, that's going to make a much more compelling experience for you. So speaking for the music industry, which I think we can because we're not in the music industry, and so, you know, like who cares what I say about the music industry? But if somebody comes up with a model that makes some pretty interesting songs in different genres, you know, bye-bye Spotify. I mean, that's going to, just imagine, why would you stream music if you could just generate it? And it's interesting enough, right? So yes, I think it's going to happen. I think the only reason it isn't happening is because it hasn't happened yet. And right now, no one is selling models. They're selling content. That's going to change.
All right, thank you.
Okay, maybe one last question from Peter. Here. Okay. So
Look at that. Double.
let's thank Harold and Fabio again. Thank you so much for coming.
Thank you.